Hi, this is Dr. Green, and we are looking at some homework examples for Session 2 homework. So, first problem here, and as always, remember that you can fast forward through the video to the question that you want, or you can back up and rewind if you want to hear the explanation again. And the written solutions for these are under the homework help link on Blackboard. So let's get started here. Problem 1, they want to know which quadrant of the coordinate system is the point 3, -2 in. And remember that your quadrants here go counterclockwise, starting with the upper right. So quadrant 1, 2, 3, and 4. And so we want to locate the point 3, -2. So that would be 1, 2, 3 to the right, and 2 down. That's going to put us in quadrant 4 here. So fourth quadrant. Not a whole lot of work to show there. We want to determine the x-intercept and then the y-intercept here for the graph below. And then our tick marks there are representing 1 unit. Okay, so the x-intercept is where it hits the x-axis here, which is at x = -2. And then the y-intercept is here where it hits the y-axis at y = 1. So x is -2 and y is 1. And let's see here. So y-intercept of 1, x-intercept -2, which is choice C. Problem number 3, we have a roast here that we pull out of the freezer, and we're letting it thaw overnight in the refrigerator. And then we're going to throw it in the oven and cook it, and then finally we're going to set it on the counter to cool before we dig into that baby. And we want to know which graph here is going to represent the temperature of the roast over time. Okay, so temperatures on your vertical, times on your horizontal. So what happens is when you take this roast out of the freezer and let it thaw in the refrigerator, the temperature is going to increase slowly. And then you throw that guy in the oven to cook it, and the temperature is going to increase faster. And then when you start letting it cool, it's going to cool, on the counter, it's going to start cooling, well, moderately fast, I guess, if it's 165 degrees internal temp. And the room temp is, 70. So, but it's going to be, temperature is going to be increasing, and then decreasing. And so we have 4 choices here. So here the temperature is increasing pretty quickly, and then it increases slower, and then it goes down. Okay, well that's out because the increase of temperature in the refrigerator, the thawing in the refrigerators happen faster than in the oven. Here the temperature increases more slowly, then increases quicker, and then decreases. This looks like B, looks like that's definite possibility. And then let's see, C, it's increasing slowly, increases quick, and then decreases quick. Look at our ending temperature here though. If you go back across here, it's the same temp as when it was in the freezer. Okay, so although this is, increase slow, increase quick, and then decrease, your temperature is not going to get back down to the freezer unless you put it back in the freezer. So this guy is out. And here it's increasing faster, which would mean, thawing and then cooking, but then it's constant temperature. Okay, when you set the roast out to cool, the temperature is going to go down. So this part right here is not correct. So this guy is out. So yeah, it does have to be B. And then let's see here, number 4, we're sketching a graph again that best illustrates a person's elevation here if they're driving from Denver west and then south to San Diego. So remember that Denver's at a higher elevation. Elevation's on our vertical, times on our horizontal. Denver's at a higher elevation than San Diego. So if you drive straight west here, let's see, your elevation's going to increase as you get up into the mountains. It might fluctuate a little bit, and then it's going to go back down. But notice here the ending elevation about the same as the starting. That's not going to happen. So this has the right general shape, but this ending elevation is not going to be the same as the starting. So that's out. Here we're increasing, at a constant but slow rate, which if you drive west until you get to the mountains, that could be true. And then you get into the mountains, and then you're at a constant elevation for a while, and then you decrease, and then you come back down to the same elevation as you started. No, that's out. Elevation's going to vary more. It's not going to be constant at the top of the mountain. It's going to, vary some. And here we got elevation is increasing slowly, then quicker, and then it tops out, comes back down, and then it ends at an elevation that's a little bit higher than what we started. Now, we're starting in Denver and we're ending in San Diego. That's guys out. So it must be D here. Now let's see if this makes sense. So we drive west, we get into the mountains, our elevation increases quickly, and maybe go up and down a little bit as you're going up and down some hills here, and then it decreases quickly on the other side of the mountains. And then as you come down, it's a more gradual slope, and as you're driving along the coast, it's almost flat, and your ending elevation here is lower than your starting. So that's definitely our best choice. Number 5, we are solving an equation for x. So let's see here. We want to remove those parentheses and change the signs. So that'll be a -5 and a plus 3x. And we're setting that equal to 43. So essentially this negative means -1. Distribute that negative sign in here. And then combine our like terms. 9x and 3x is 12x. Minus 5 is equal to 43. And we want to isolate that x term, so add 5 on both sides. And these guys cancel. We get 12x is 48. And then we want to divide off this 12 on both sides to undo the multiplication. And those 12s cancel, and we get x equals 4, which is B. So that's a linear equation. Remember, your strategy is always get your x terms on the left-hand side, all your numbers on the right-hand side. And let's see, number 6, we're solving a linear equation with constants in the denominator. So we want to solve this equation for x. And whenever you have fractions like that, you want to get rid of those fractions. And you're going to do that by multiplying through by the LCD. Let me bring this equation down here. Let's see, least common denominator of everything is 20. Everything divides into 20. Okay, so let's multiply both sides by 20. So this will multiply in times each piece. And then multiply on the right-hand side also by 20. That guy's going to multiply in times each one. So let's see, when you do 20 times x over 10, 10 goes into 22 times, and then 2 times x, 2x. This minus sign right here, 20 times x over 4, 4 goes into 25 times, and then 5 times x, 5x, equals 20 comes in times x over 20, 20s will cancel, we're just left with x, minus 20 comes in times 4/5, so the 5 will cancel into the 20 and leave a 4 times the 4 that's already there, 16. And let's go ahead and combine our like terms on the left. So that gives us negative 3x is equal to x minus 16. We want our x terms on the left because this is a linear equation, so subtract x on both sides. These guys cancel out. We are left with negative 4x on the left-hand side equals negative 16 on the right-hand side. And now we want to divide off that coefficient of negative 4 on both sides. These guys cancel. X is negative 16 divided by negative 4 is positive 4. And that is choice C. And then number 7, similar to what we did up above, except now we've got variables in the denominator. But we're going to do the same thing that we did before. We want to multiply through and clear out fractions. Multiply through by the LCD to clear out fractions. And when we do that, then we'll have an equation that no longer involves fractions. So let's see here. We want the smallest expression that 4, 8x, and 3 all divide into. So, well, 4 goes into 8. So 4 will go into 8x, but the 3 doesn't. So we need an extra factor of 3. So it looks like it would be 24x would be the smallest expression they all go into, the least common multiple. So we're going to go ahead and multiply that in on each side. So 24x times 5 fourths. So this 4 is going to cancel into the 24 6 times. So that'll leave 6x. This minus sign right here. 8x cancels into 24, leaves a 3 times the 5 there. So 6x minus 15. 24x comes in times the 4/3. The 3 will go into 24 8 times. So that leaves an 8x times 4, 32x. And then 24x times 8x. So the 8x will cancel into 24 and leave a 3 times 5 is 15. And we want numbers on the right, variables on the left. So let's go ahead and subtract 32x on both sides. And let's go ahead and add 15 on both sides. That'll bring that negative 15 over on the right as a positive. So these cancel, these cancel. We've got 30 left on that right-hand side. And then on the left-hand side, 6x minus 32x. Oh, you know what? I'm sorry. This 6x should actually be 30x, because 24x times 5 fourths, the 4 does cancel into the 24 and leaves 6x, but then that's times a 5 that's out in front. So this is actually going to be 30x. And now 30 minus 32x is going to be negative 2x equals 30 here, and then divide both sides by negative 2. And those guys cancel. X is 30 divided by negative 2 is negative 15. And that is choice C. So that one's all set. So multiply through by the LCD again to clear out the fractions. And now we're finding the value of x that satisfies the conditions y1 is x minus 2 over 2, y2 is x plus 3 over 5, and then y1 minus y2 is equal to negative 1. So take this expression for y1 and plug in here, and take this expression for y2 and plug it in here. If you do that, you get this equation. So the x minus 2 over 2 here, and then minus the x minus 3 over 5 there. So now we've got an equation that's got fractions in it, and we want to multiply through by the LCD to get rid of those fractions. Least common denominator here is 10. So we'll multiply by 10 on the left, and then also on the right. So let's see, 2 goes into 10 5 times, 5 times the x minus 2. Minus, let's see, 10 comes in here, 5 goes into 10 2 times, and then 2 times the x plus 3. And then on the right-hand side, negative 1 times 10, negative 10. Okay, so now we want to multiply everything out. So 5 times x, 5 times negative 2, so 5x minus 10. And then let's change this to plus negative 2, and then multiply that negative in. So negative 2 times x, negative 2x, negative 2 times 3, negative 6, equals negative 10. Combine our like terms here, 5x and negative 2x is a 3x. Negative 10 and a negative 6 is negative 16. equals negative 10. And now let's get the negative 16 over on the right. So add 16 on both sides. So these guys cancel. We are left with 3x is equal to 6. And then we divide the 3 off both sides. These guys cancel. X is equal to 2. And looks like that's choice A. So knocked that one out. Again, multiplying through by the LCD to clear out fractions. Number 9, a number is decreased by 30% of itself. Okay, and then the result is 28. What's the number? And they ask us to use the 5-step strategy for solving word problems. Okay, so step 1 is to let x represent your unknown quantity. So a number, that's what we don't know. So that's going to be our x. And so x is the number. And then let's represent the other quantities in the problem. So 30% of itself, so itself is x. So 30% of x is what we want. And of means multiply, so that's just 0.30x. And then step 3 is to write our equation. So the number x is decreased by, so that's a subtraction, 30% of itself, which is 0.30x. So our equation is x minus 0.30x. And then the result is 28 is equals. So equals 28. And now we need to solve that equation. So these are like terms. This is 1x minus 0.3x. So 1 minus 0.3 is 0.7. So that's 0.70x equals 28. And then we divide by 0.7 on both sides. So these guys cancel. And that gives us x is equal to 40. Okay, and now we can check our work. Okay, so we took our number x, which is 40, and then we decrease it by 30% of itself. So minus 0.3 times 40. And what do we get? Well, that's going to be 40 minus 3 times 4 is 12. So 0.3 times 40 is also going to be 12. So this is 40 minus 12, which is 28. And that is indeed what we wanted right here. Wanted 28. So x equal 40 is our solution there. Oh, not one of the ones listed here. So typo. D. There we go. And let's see. Up next, we are finding value of x that satisfy the conditions. Y1 is 4x minus 3. Y2 is 2x plus 6, and Y1 exceeds, so it's bigger than Y2 by 9. So if Y1 exceeds Y2 by 9, that means that Y1 is equal to Y2 plus 9. Okay, because you have to add 9 to Y2 to get up to Y1 because it exceeds it. So where there's Y1, we're going to plug in 4x minus 3. Where there's Y2 here, we're going to plug in 2x plus 6. And we got that plus 9 on the end. So this is going to be 4x minus 3 is equal to 2x plus 15. Now we want x's on the left, numbers on the right. So let's subtract 2x on both sides. And then let's see, add 3 to both sides to undo that subtraction. So these guys cancel. 4x minus 2x is 2x is equal to 15 plus 3 is 18. So that's going to tell us then, dividing by 2, that x equals 9, which is choice B. And let's see, during your lifetime, you will devote 15 years to driving and waiting. The number of years waiting will exceed, so it's bigger than the number of years driving, by 7. Over your lifetime, how many years will you spend on each of the activities? Okay, so let's let x equal the number of years spent waiting, okay? And 15 is the total of driving and waiting, okay? So then that means that 15 minus x, the total minus x, is going to be the number of years for driving. So now we've got both expressions, both quantities in terms of that one variable. And then we know that the number of years waiting exceeds years driving by 7. So if you take your years driving, add 7 to it, you're going to get years waiting. Okay, so years driving is 15 minus x. And if we add 7 to that, then we will get years waiting, which is x. And now we just need to simplify and solve this equation. So let's see, 15 and 7 is 22, so this is 22 minus x is equal to x. Already got numbers on the left. Why don't we add x on both sides here? So we got 2x on the right. These guys cancel. 22 on the left. So 2x is equal to 22. Divide both sides by 2. X is going to equal 11. So 11 years waiting. And then 15 minus x, 15 minus 11 is 4 years, and that's driving. So 11 years waiting, 4 years driving, C. And also, as you look at these answers, I mean, you know some of them right away are out because they don't add up to 15, because 15 is the total. So 13 and 8, that's out, doesn't add up to 15. 6 and 9, that adds up to 15. 5 and 10, that adds up to 15. And then they say that the years waiting exceeds years driving by 7. Well, here, years waiting is 6 and years driving is 9. So that's out because the years waiting doesn't exceed years driving. If it exceeds, it's bigger. So this guy's out. And then this one would be out also. Because here your years waiting is less than years driving. That can't happen if years waiting exceeds. So that's out. So you actually could determine this solution, this particular one, just by using the relationships in the problem and elimination rather than solving the equation. And if you want to do that, that's okay. You can do that. I don't believe you have to show your work on this homework. And let's see, number 12, a one-day Disney theme park ticket cost $120. And Florida residents have an option of purchasing an annual discount pass for $450. And then with the discount pass, then the day pass is reduced to $30. So you buy, $450. You can use it as many times as you want in a year, and instead of paying $120 each time, you pay $30 each time. Determine the number of times per year that the pass must be used so the total annual cost without the discount is the same as total annual cost with the discount. So without, same as with. So we need to have an unknown here, and that's what they're asking us to find, the number of times a year that the pass is used. So let x equal the number of days that your annual pass is used. And then what's your cost without the discount pass and your cost with the discount pass. So without the discount pass, you're going to pay $120 a day, and then x is the number of days. So without, you're going to pay 120 times X, price per day, number of days. With the annual pass, we want these to be equal now. You're going to pay $450 up front, but then you're only going to pay $30 per day. So $30 per day times X days it's used is going to give the total spent on the per day charges. So now we just have to solve this equation. So let's go ahead and subtract 30x on both sides. So the equation's not hard once you got it. So that leaves us 90x on the left-hand side equals, these guys cancel, 450 on the right-hand side. 9 goes into 45 5 times. So 90 is going to go into 450 5 times. So x equals 5. So you have to use that guy 5 days when you break even, and then after that you're saving money using the discount pass. Okay, solve the equation using square root property. So by taking square roots of both sides. So x plus 6 squared is 64. So we can take square roots on both sides. And then the square root of x plus 6 squared is x plus 6, and it's actually absolute value of x plus 6 because x plus 6 could be positive or negative. So to compensate for that, when we do square root of 64, we're going to introduce a plus or minus sign. So positive or negative 8, because this x plus 6 could be positive or negative. And now subtract 6 on both sides, so that comes over as a negative. So your x is going to be equal to negative 6 plus or minus 8. So negative 6 minus 8 is negative 14. Or negative 6 plus 8 is going to be positive 2. So negative 14, positive 2, that's D for our solution set there. So that's square root property. And then number 14, they want us to solve using quadratic formula. Okay, so I went ahead and wrote the quadratic formula for you here. The A is 2, the B is 5, and the C is negative 1. You always include the sign out in front with the ABC. So the negative of B, that's going to be negative 5 plus or minus square root B squared, so that's 5 squared, which is 25, minus 4 times A, which is 2, times C, which is negative 1. And then that's all over 2 times A, 2 times 2. So this is going to be negative 5 plus or minus square root. Let's see, 4 times 2 is 8 times negative 1 is negative 8. So 25 minus negative 8, 25 plus 8. So that's going to be 33. And then we are dividing by 2 plus 2, which is 4. And so now we can split these apart over the LCD if we want to, or we can leave them like this. It just depends on what form your answer is in. And I think on this particular problem, they want you to express your answer as the rational part plus or minus the irrational part. So we can break this apart and write it as negative 5 over 4 plus or minus the root 33 over 4. So we just split them apart over the LCD. And there's your final answer. And I think this one you're showing your work for. And let's see here, Pythagorean theorem and the square root property is what we're using to solve here. And we're rounded to the nearest tenth. So you got a 40-foot rope that runs from the top of a flagpole to a point on the ground 8 feet from the base. So that's going to look like this. So here's your 40-foot flagpole. Or no, I'm sorry, 40-foot rope. here's the ground here. Here's the flagpole. And there's the stars and stripes waving in the wind. And we got this rope that's anchoring that flagpole. So this is 40 feet. And it hits down here 8 feet from the base of the pole. And we'll assume that that pole is sitting straight up. So that's a right angle. So then this height is what we want here. How tall is the flagpole? So these are the two legs. Here's our hypotenuse. So the sum of the squares of the legs, h squared plus 8 squared, has got to equal the sum of the hypotenuse, 40 squared. So this will be h squared plus 64 is equal to 40 squared, 1600. And then subtract 64 on both sides. So these guys cancel. And so h squared is going to be 1536. And then take square roots. And we want the positive square root. So positive square root of 1536 is about 39.2 to the nearest tenth of a foot. And that is choice C. And let's see, next up here, we've got a machine that produces open boxes using square sheets. So this is a square sheet of cardboard. And the machine's going to cut equal size squares that are 4 inches on the side from the corners. So the white areas are the squares, 4 of them, cut from each of the 4 corners. And that shapes the cardboard into an open box, and you turn up the sides along the dashed lines here. So each box must have a volume of 324 cubic inches. Find the length and width here of the open box. And they've given us here that the length and width are both x, and so it's a square base, so they should both be the same. And what we know also is that the volume is 324 cubic inches. So the volume here is going to be length times width times height, and the length and width of the box are x and x. And then the height, well, this right here folds up to make the height of the box, and that is 4 inches. Okay, and so it's going to be 4 inches on each side. So your height is 4, length is x, width is x. So that volume is actually 4x squared. And that's got to equal 324. And so now we divide both sides by 4. And that's going to give us x squared is 81. 4's cancel. And take square roots on both sides. Square root of 81 is 9. So x is equal to 9. So length and width are both 9. And that is choice C. And then 17 here, we're solving this polynomial equation by factoring and then using zero product principle. So that's where you set each of the factors equal 0. So what we want to do here is, since this is a higher order equation, it's not linear, what we want to do is we want to get everything on one side, everything on the left hand side, and then we'll factor and set each factor equal to 0. So since our highest power is the z cubed, and that's on the left-hand side, let's take these terms and bring them over on the left. So let's go ahead and subtract 75 from both sides, and then add 12z squared to both sides. So on the right hand side, both of those cancel. We are just left with a 0. On the left hand side, we've got that 4z squared, or I'm sorry, z cubed. We've got plus 12z squared. and then plus 12z. Got to move our 0 over. And then minus 75. And actually, I just noticed a typo here. Let's see, this 12z, that should actually be 25z. And here 25z, and here 25z. I think that's already correct on your copy. There we go. And let's see, in these first two terms, we can go ahead and group. We got 4 terms, so we're going to do factoring by grouping. In those first 2 terms, 4 is common and z squared is common. So we can factor out a 4z squared. Z will be left in that first term. And factor 4z squared out of 12z squared, you'll have a plus 3 left. And then 25 is the common factor between 25 and 75. So you can pull out that 25. Z is left here. Minus 25 goes into 75 3 times. And let's see here. And, oh, yeah, I'm sorry. This actually should be negative 25z. Negative, negative, negative. So we actually want to factor out a negative 25. And factor the negative 25 out of here. Z is left. Factor negative 25 out of there. 3 is left. So now z plus 3 is a common factor. So we can factor out that z plus 3. 4z squared is left here. And minus 25 here. And then 4z squared minus 25, that is a difference of 2 squares. So this factors as z plus 3. And then 4z squared, that's a perfect square. That's 2z quantity squared. So this is going to break down as 2z and 2z, and 5 is a perfect square. So these last terms will be 5 and 5. And we want one of them to be plus and the other minus, because then our outside-inside terms cancel out. Set that guy equals 0. So now if that product is 0, each piece is 0. So either z plus 3 equals 0, which makes z negative 3. Or the 2z plus 5 is 0, in which case you can bring the 5 over as a negative and divide by 2. Z is negative 5 halves. Or the last piece, 2z minus 5, is equal 0, in which case bring the 5 over as a positive, divide by 2, z is 5 halves. So plus and minus 5 halves, or negative 3, which is B. And in number 18, we are solving an equation here with rational exponents. So x minus 2 to the 3/4 power is equal to 64. So remember what that means. There's a few different ways to do this, but remember what that means is the 3rd power and the 4th root. So you can write this as the 4th root of x minus 2 to the 3rd power equals 64. So the number on the top is the power and the number on the bottom is the root. So it's the power divided by the root when you've got fractional exponents. So if we wanted to, we could take a cubed root on both sides and then take a 4th power on both sides. Or if we want to, we could do things all in one step. We could do that by taking 4/3 power on both sides, whichever one you like. I'm going to go ahead and do everything at once. So the way that you undo a 3/4 power is you take a 4/3 power on both sides. And then here we've got power to a power, so you'd multiply those exponents, but 3/4 times 4/3 is 1, so those cancel out. So we get x minus 2 is equal to 64 to the 4/3 power. And so that is the cubed root of 64, because the bottom number is the root you take, and then 4th power. And the cube root of 64 is 4, and then the 4th power of 4 is 256. And then add 2 on both sides. So your x is going to be 256 plus 2, which is equal to 258. And if we look over here, that is choice B, 258. So we're all set there. Number 19, speed of a tsunami, S, in meters per second, in water that is d meters deep is given by S equals the square root of 9.8 d. And if we know the speed of the tsunami is 15, how deep is the water? Okay, so they're giving us S and we need to find d. So S is equal to 15, and the question is, what's d? So we'll plug in 15 here. So we get 15 is equal to the square root of 9.8d. And so we're going to undo that square root by squaring on both sides. So we get 225 on the left-hand side equals square and square root cancel each other out. They undo each other, 9.8d. And then divide off that 9.8 on both sides. And 225 divided by 9.8 rounds to the nearest tenth. Here's what we want. This is actually 23.0 rounded to the nearest tenth. 9.8's cancel. That's D, which is answer C. So you just got to remember you're undoing operations here. Work from the outside in. And then lastly, number 20, finish up here. We're using Pythagorean theorem, a squared plus b squared plus c squared, to solve the problem. We've got two vertical poles, length 6 and 8 feet, and they are 12 feet apart. So here's our 8-foot pole, our 6-foot pole, 12 feet apart here. And then a cable reaches from the top of one pole to a point on the ground between the poles, and then the top of the other pole. Where should that point be located to use 20 feet of the cable? So the total here of these two lengths is 20 feet. So this is our cable running down from one pole and then to the top of the next one. And our answers, they're telling us either 2.3 or 10.8 feet from the base of the 8-foot pole. Okay, so that's giving you this length right here. Okay, so that's the way they pose the problem. That's our unknown. So let's let that be our x. And this whole thing is 12. So that means that this piece down here has got to be 12 minus x. So that's this one. And then our x is right here. And what we know is that the hypotenuse of this triangle plus the hypotenuse of this triangle gives that 20 feet. Okay, so, well, what's the hypotenuse of this triangle? Okay, well, let's call that length 1, L1, and let's call this one length 2, L2. And what we know is that if we square these two sides, we get the square of the hypotenuse. So if we take x squared plus 8 squared, that's going to give us length 1 squared. And if we do Pythagorean theorem on this triangle, square the two legs and add them, we get L2 squared. So if we do the 12 minus x quantity squared, and then add the 6 squared, we're going to get that second length squared. And what we know is if you add those two lengths, L1 plus L2, you've got to get 20. So what we can do is we can take square roots on both sides here. So that's going to give us length 1. And take square roots on both sides here. And that's going to give us length 2. And if you add these two guys together, so if you plug them in here, you get 20. And I actually went ahead and did the steps for this because it's kind of a long problem. Let's take a look here. So x is at distance from the 8-foot pole, and then this is the equation from up above. This is length 1, and then this is length 2, and then they add up to 20. So what we want to do here is solve this radical equation. So we got roots in there, so we got to undo the roots by squaring on both sides. But you first have to move one of these roots over to the other side. You got to isolate the roots, remember, first. So I'm going to take this guy and subtract it on both sides. So it comes over here as a negative. And then I want to square both sides of this equation. Okay, so I went ahead down here, move this down here, and then take this guy and move it down here. So then square the left-hand side, and that's got to equal the square of the right-hand side. Okay, well on the left-hand side, the square and the square root, they just cancel each other. So you just got what's inside, 12 minus x squared plus 36, and then this guy squared over on the right. So left-hand side we're going to leave, left-hand side we're going to go ahead and FOIL this out. 12 minus x times 12 minus x. So first terms 12 times 12, 144. Outer terms negative 12x, inner terms negative 12x, that's negative 24x. Last terms negative x times negative x plus x squared. And then this 36 is right here. Right hand side we've got this whole quantity gets squared, so here it is times itself twice, and now from here to here left hand side stays the same, but right hand side all I did was multiply this out. So first terms 20 times 20, 400. Outer terms negative 20 root x squared plus 64. Inner terms another negative 20 root x squared plus 64, which makes a negative 40 root x squared plus 64. And then last terms, root x squared negative times negative is positive. Root x squared plus 64 times root x squared plus 64 is the root of x squared plus 64 squared. And then the root and the power undo each other. You're just left with x squared plus 64 right here. So now we got rid of one of the radicals by doing that. So we're left with one radical here. We want to isolate that and then square again. Well, first notice we've got an x squared that's common on both sides, so we can subtract that off. And then 400 plus 64 is what's left. Okay, so what's left on the right hand side here, 400 minus 40 root x squared plus 64 plus 64. On the left hand side, 100 minus 24x here, and then the 36 I brought down. So now let's combine some like terms here. So 140 plus 36 is 180 right here, minus 24x, I just brought that straight down. On the right hand side, 400 plus 64 is 464, and then this term I just brought down here. Now the 464, we're going to bring that over on the left hand side as a negative. So 180 minus 464, that's this negative 284. And then the negative 40 root x squared plus 64 is all by itself here on the right hand side. So Now what I did to get from here to here is I multiply both sides by -1. So multiply this left-hand side by -1, it changes both those signs. Multiply right-hand side by -1, changes that sign. That's what this is. And then from here to here, I squared both sides. So here's the square of the left-hand side, and then here's the square of the right-hand side. So now, this I FOILed out. Okay, so that's 284 plus 24x times 284 plus 24x. So the 284 times 284, that's 80,656. Outer terms, 284 times 24x. Inner terms, another 284 times 24x. Combine those, you get 13,632x. And then the last terms here, 24x times 24x is right here, 576x squared. And then on the right-hand side, to square this right-hand side, you square the 40. 40 times 40 is 1,600. And then you square the square root, and they cancel each other here. And you're just left with that x squared plus 64 right there. Then multiply your 1,600 in. 1,600 times x squared right there. 1,600 times 64 right here, 102,400. So now we want to take, and we've got the bigger x squared term on the right, so we're going to take all of these guys and move them over as negatives. So 1,600x squared minus 576x squared leaves us 1,024x squared. This guy comes over as a negative, right there it is. And we got 102,400 minus 80,656, that's the 21,744. And then 0 is left on the other side. And now this is all set up for quadratic formula. So A is 1,024, B is negative 13,632, and C is 21,744. So here's our quadratic formula. Here's negative b plus or minus, there's our b squared, minus 4 times a is 1024 times c is 21,744 over 2 times a. And if you simplify this on the calculator, you'll get either 1.85 or 11.64. So to one decimal place, that would be 1.9 or 11.6 for your x. And let's see here. 1.9 or, yeah, I'm sorry, this should be 11.6. 1.9 or 11.6 feet from the base of the 8-foot pole. That's what we wanted right there. Now, this is a super long process, and it's probably kind of confusing because you've got a lot of messy algebra, and your problem is pretty similar to this, and it's got a lot of messy algebra. So since this is a multiple choice question, let me suggest another way that you could do this. Another way that you could do this is you could take that 1.9, plug it in for x here, so plug it in for x here, and plug it in here, and add these guys together, and then square root them, and see if it adds up to 20. If it does, then that's the right answer. Then do the same thing with the 11.6. And then you can just do this by a process of elimination. So if you plug the 2.3 in for x here and here, so in other words, you're plugging it in here and here, you would not get 20. Same thing for the 3.2 and the 4.5. You plug in here and here, you're not going to get 20. So you know once the first one doesn't work, you know that that's out, and that's out. You plug in the 1.9, you're going to get pretty close to 20. And then you plug in the 11.6 here and here, you're going to get pretty close to 20. And then you know that's the right answer. So for a multiple choice question where you don't have to show your work, you've got another way to tackle that problem. All right, so hopefully these problems should be pretty similar to what you got to do on the homework assignment. So hopefully this helps you out on that, especially this last problem, super hard, super messy. So don't get discouraged if you were not able to follow, what I was doing down here. That's an awful lot to follow with all the big numbers and the multiplications and a lot going on there.